Albert Einstein, arguably the greatest genius mind to have been born on this planet, is the man in focus in this presentation. He had reached fame levels unprecedented for a physicist just at the start of his career. Although the big man received the Nobel Prize for his contribution towards the photoelectric effect, he is better known for his theory of general relativity, one of the two pillars of modern physics. In its application of classical mechanics, the principle of relativity is hardly new, but the same principle did not seem to apply to electrodynamic phenomena. The laws of electrodynamics made an explicit reference to the velocity of particle while assuming an absolute inertial frame of reference. How this seemingly simple but strange concept came to Einstein is interesting. In one of his thought experiments, Einstein observed some strange symmetries in electrodynamics which was considered mere coincidences till then. Imagine that a wire loop passes between the poles of a magnet with a certain velocity with respect to the magnet. The free charges in the wire, being in motion with respect to the magnet, suffer a magnetic force, leading to motional EMF minus d phi by dt. But in the frame of reference of the wire loop, the charged particles in the loop are at rest, hence they should not suffer any magnetic force. But since the magnetic flux is constantly changing through the loop, EMF must be induced in the loop according to the Faraday's law, E is equal to minus d phi by dt, which is exactly the same in magnitude as predicted in the frame of the magnet.
To his predecessors, the symmetry of the two events seemed a mere coincidence, and they had no doubt that one of the observers was wrong. They believed in a medium of absolute rest called ether through which EM waves propagate. But Einstein was not the one who was ready to accept the two interpretations as different and the result a mere coincidence. In fact, he took this observation as a clue in the favor of relativity being true even for electrodynamic phenomena, as he published his famous paper on the theory of relativity in 1905. His theory, once and for all, threw the concept of ether off the shore. He laid the following two postulates in his theory. First, the laws of physics apply to all inertial reference frames, and second, the speed of light in vacuum is the same for all inertial frames regardless of the state of motion of either the source or observer. Now the natural question that arises is that how could such a seemingly simple thought not occur to some other physicist? Well, the answer is that Einstein's theory had some very weird counterintuitive implications that were completely out of sync with common sense. Take the example of Einstein's velocity addition rule, which deviates from that of Galilean or the so-called normal velocity addition rule. Einstein's theory compels us to transform our previous notions on space and time, and hence any derived quantity.